Hello and welcome back. So in the previous video, we looked at some data structures, some of the basic data structures we have in Python, and then we made mention of the list, the sets, the tuples, and then the dictionaries. There are other more different variations or different variants of these data structures, but then our focus is just on this main four. Okay. So in this video, we would look at how to get each element or retrieve elements from these data structures that we spoke about in the previous video. So without wasting much time, let's get started. So to begin with, I would create a file. I think this time I'll call it 9 data elements or elements from data structures ds.py. So now I close this one and then I make use of the environment. Okay, so once more, ensure that you have your scientific environment activated. If you don't know how to do it, you can go watch our setup video or the second video after that. If you are new here, welcome. And then you can also go and then rewatch the previous videos before you come here. So basically, we spoke about lists. So we said that the main focus or one main reason or use of lists in scientific computing with Python is that we can use it to represent arrays or vectors or matrices, as we know. So if I create a list, we said we can use the square bracket to create a list. So if I have my vector 2 with these values 5, 7, 9, then if I'm interested in maybe the value 3 or each value of this list, all I have to do is to call the list. So if I want to print the list and I want to print each element of the list, I can just do a and then square bracket, and then I put the index of the elements. So one thing you have to know is that Python is zero indexed, which means that if you want to get each element from this list, you would the index of this list, this element is 0, the index is 1, the index of this one is 2, 3, 4, going. So if I should print the A and then get the index 0 element, if I should save this and run this code, I should get this. So I do Python, then that. You realize that I get 1 here, right? So basically this is, so if I should change this to, and then this to 1, okay, let's do 1, 3, and then probably -1. So here you could see that if I rerun this code, I get the elements 1, 2, 5, and then 9, right? So basically we use the -1 to get the negative indexes or indices to get the last elements, right? Elements. So -1 will give us the last, the -2 give us last but 1, the -3 give us last but 2, and then and so forth and so forth. Get the fourth element, right? And then this gives us the second element. Okay. And then the first element of our value. So this is how we retrieve values from our arrays or our list. Bear in mind that we could have used variables or strings here too as well. So I can bring Kofi, and then if I had declared a variable called maybe age, then let's say 56, then I can include that variable here too as well. So keep that in mind. It's just that we are trying to focus more on the mathematical concept so that we look at how we can use this to do some scientific computations. So anyways, so now if I reprint this, the last element becomes age, which is 56, right? So if I rerun this code, I should get 56 here. So which means that if you use -1, you are not always guaranteed to have the same value as long as the list is not fixed, right? The list keeps growing, then the negative one values will also keep changing. So you can use this index or the negative one index if you don't know the index of the last element, but you still want to get the values anyways. Bear in mind that these indices are just placeholders that represent where these values are stored, right? So to get them, you have that. Okay. So quickly, let's look at how to change or edit, right? Edit a list. So to change the value, so let's say for instance, I want to change the first value. All I have to do is call the index of that first value, that's 0, and then reassign it to maybe something else, science or physics, something like this. If I should save this and rerun, and then let's say I reprint this statement here, you could see that before then the A0 was 1, and then now if 0 is for physics, you could change it to anything. So this is how you can edit or edit your vectors, right? So if you want to maybe change the value of the second value of a vector into something else, all you have to do is just do this, call the vector and then the index of the value you want to change, and then you get that. Okay, so this is how we add or edit something. Sorry, if you want to add, all you have to do is use the append. So add elements to lists or arrays, whichever. All you have to do is just do a dot append, right? And then you can put any value here. So I want to append 23, 46. If I should print A, bear in mind that printing A will print all the lists, right? We are interested in printing A. What then happens? So you see, we said in a previous video that these, once the values are separated by commas, it is regarded as what? A tuple, right? Now you've given it certain values, but then the append takes just one value each, right? So you append a value one after the other. So if I do this and I rerun this code, I don't expect to see the error again, but then I can see the 23 here. So you can append elements by element. Always keep that in mind. Lists could also contain other lists, but that would be a topic for a different video. So now that we know how to add elements, we know how to edit, now let's look at how to delete or remove. Bear in mind that this is not the only method we can use to add. We can also do insert, but then that is when we want to insert some values in a particular index, right? Okay, so keep that in mind. So here I want to delete. This is just to give you a concept, right? How to do this. So if I want to delete, you can decide to use a.pop, right? And then this pop by default will remove the last element from your list and then store it or save it temporarily, which means you can reassign the last element. So if I say last element, I can just say last element or last value is equal to a.pop. Then I can decide to print a, and then print the last value here. So now if I rerun this code, you see that the A is here without the 23, which is the last element, and then now the last element has been held. So you can use the pop if you want to remove the last elements and still keep the value, or you want to delete a value from a list and still keep the value. You could also decide to pass an index to rate. So let's say if I want to delete the third or the fourth value from that, I just pass the index, and when I rerun it, I expect that the fourth value, which is 5, should be removed, right? So which is this. Now it has been removed and it has been stored for us. So basically, this is how we pop elements from the list. Could also decide to delete or remove. So you can say a dot remove, and then now that you want to remove, would you want to remove? So you can just say remove 2, right? Now in this situation, the 2 here would be, if I print a here you can see that if I save and I rerun this code, you see that the 2 is gone, right? The value 2 here is gone, not the index, the real value. So you can use the remove method to remove the specific element we are interested in. Bear in mind that the pop uses the index, right? If you don't give it an index, it removes the last element by default. And then the remove, you pass the elements, exactly the elements you want to remove from the vector or from the array. So basically, this is how we add, delete, retrieve, and edit a list. So, but then if we would want to retrieve all the elements from this list, then instead of typing them one after the other, we can use loops to retrieve all the elements. But that will be a topic for another video. So quickly, let's look at the other data structure that would want to see it, which is a tuple, right? So basically a tuple, we said, is an immutable list, which means that it has the same properties as a list, just that this time once you create a tuple, you cannot change it. You cannot edit the values. So let's say, and we said that the tuple is just determined by a comma. So which means that you can even form a one value tuple by just writing 2 or 3, let's say 2, comma, like this. And then C will be regarded as a tuple. So given these tuples, we can actually get these elements. They're just similar to the Python list. As you said, these are immutable lists, which means that to get the elements from that, all I have to do is bring the tuple and then the index, right? So this is also 0 index. And then if I say, let's say print b index 0 or elements from that, if I rerun this code, I'm expecting to get 3. Okay, so first let me print the tuple. The tuple is then we learned from the previous video that we can print the values of a variable by using the Python formatted string, right? So to do that, that's we use the f string. So the tuple is this, and then the first element is that. So I can save this code and rerun it so that we see that we have this tuple, and then this is the first element. We can get the third element to like that. Okay. So basically, this is how we get a tuple. To confirm that we can't change the values, it means that we can't edit it, right? So if we try editing, like by saying a 0 index, sorry, b index, let's say 0 to be equal to 5. If I should save this and run this, I'm expecting to get an error. You see, so we are being told that tuple does not support item assignment. So which means that I can't actually I can't edit the values of the tuple. What if I try to add, right, by using the append? This is something, add elements. So if I do so we try the append and see whether it will allow us to add something to it. So if I do b dot append 2 or something, if I run this, let me comment this one out because this will do its work. Let's check whether it will allow us to add something to it. So the same thing has no attribute append. So it means that there is no method called append on this list. What about pop? It has, hopefully it shouldn't, because okay, so it has no attributes called pop. So which means that once you assign this unless you reassign the whole tuple together. You can't. So we can only read elements from it. If you want to read or get all the elements from the tuple, you would have to loop through the tuple to get every element through in the tuple. So that's all for tuples. Then to talk about sets, right? So we said the other time that sets allowed us to get only unique values from any list. So if I have any list above, let me check my lists. Okay, so I can create a list with, so let me have B to be equal to a list of 1, 2, 2, 3, 4, 5, 5, 7, 8, 8, right? And then if I form a set out of this, I can have set B to be equal to the set of B. So this is a different way of using sets or declaring sets, right? If I print set B, let's see what happens here. So if I should print set B, I get the unique elements, right? But then be that as it may, this gets us only the unique elements. But then the problem here is that we can't actually get the index, right, of the set. In as much as we can access the elements from an array one after the other by using their indices, we can't actually do that with sets, right? The only thing we can do for sets to get the values is to loop through them to get each value. So it means that we cannot exactly get the elements from a set by referencing their index. Why? Because the sets, these are not ordered, and then you don't actually know the exact position where each element is in the set. So it means that the only way we can get the elements from the set is if we loop through the set to get its elements. And then we would look at that after doing for loops or while loops, and then you see how best we can get elements out of a set. Bear in mind, this is a different way of declaring a set or getting a set out of a list. You can also get a list out of a set by just saying, let's say list B should be equal to lists of set B this way. Then this way, this would give us the lists made out of the set, right? So you can use this to actually get unique values. So you get the values that are here, you don't know whether they are unique or not. You convert them to sets and then convert them back to lists. Then this will give you a list or a set or a list with some unique values. Okay, so now the next one we look at is dictionaries. So dictionaries are also one of the data structures we spoke about in the previous video. And then we said that dictionaries are represented using key value pairs. So if I have my dictionary D to be equal to the parentheses, and then I want a name. So if I have the name and then assigned to the value sedem or bakar, then age assigned to the value maybe 23, then it means that to get these values from the dictionary, all you have to do is just reference the keys, and then that will give us a value. So if I do D, capital D, square bracket, name, and I choose to print this one, I choose to print name dash that, I should get bakar, the value bakar from here, as you can see here. So basically, this is how we get elements from the dictionary. So I can copy this and then change the key here to age. And then I would also retrieve the value of the age, that's 23. So basically, this is how we retrieve elements from dictionaries. If you want to edit elements or edit a dictionary, all you have to do is the same thing. you reference the age or the elements you want to change, and then you give it a new value, 25. Then this way, if we print the dictionary D, we expect that we get the new age assigned as 25. So this is how we edit the dictionaries or the values of keys in the dictionary. And then this is how we retrieve the values inside the dictionary. Bear in mind that we could also retrieve every element from a dictionary by using a for loop. You can also use the get function to get some values from the dictionary. So all you have to do is, let's say print d.get, and then I want to get the age. Right now, when I save and I rerun, I expect to get the age, right? So you can either use this one or you use the .get method on the dictionary to get the value of the key you are interested in. All right, so now let's look at how to delete elements or remove elements from a dictionary. So all you have to do is just say, use the del function, and then we apply to the dictionary. So we can say delete what D and the key age. So when we do this and we print D, I expect that if I print D, all I have to get is a dictionary that contains only the name. So to delete, you can use the del, that's the delete, or you use the pop, right? So you can actually pop values from a dictionary, just like we pop values from a list as well. So all you have to do is write D, the delete dot what pop. Then you pass the name of the key, right? The key I want to pop is the name. So all you see here is, if I rerun this and I reprint the D here, I should see an empty dictionary here. So if I rerun, I should see an empty dictionary here because we popped the name out. So basically, this is how we retrieve. If you want to add, sorry, I didn't look at add. So if you want to add elements to a dictionary, so adding elements to dictionary, all you have to do is to just reference the dictionary D and then the new key you want to add. So let's say I want to give it a P, and then you assign the P to what? The value, so 559. But when I save it and I print the dictionary, I expect that I see that. So you see that now the dictionary now has a key called P with a value that. So basically, this is how we operate on dictionaries. If you want to retrieve every element, as we said, for all the data structures, you would have to loop through them in order to get all the elements. And this would be a topic for another video. So that will be all for this video. If you've learned something from this video, don't forget to like and subscribe and share with your friends so that they could also learn from this video. And we can't wait to see you in the next one. Thank you.